Hello, welcome to today's lesson on static electricity. Today we will understand what static electricity is and how it differs from current electricity. We will then apply static electricity concepts to explain everyday examples such as why hair stands up after combing and how a charged balloon can stick to a wall. So far, in our discussion of electricity, we were referring to current electricity, where there is a continuous flow of electric charge through a conductor. In this lesson, we will examine the other type of electricity, static electricity. Have you ever tried rubbing a balloon against your hair and then sticking it to a wall? The attraction between the balloon and the wall is due to static electricity. In this lesson, we'll explore what static electricity is, how it arises, and how it compares to current electricity. Static electricity is the buildup of electric charge on the surface of objects. This is different from the concept of current electricity, which we discussed in previous lessons. In current electricity, there's a continuous flow of electric charge through a conductor, such as a wire. However, in static electricity, the charges accumulate on the surface of an object and remain stationary, hence the term static. Before we dive deeper, let's recall the basic principles of attraction and repulsion between charges. Objects with different types of charge attract each other. For instance, a positive charge and a negative charge will attract each other. Conversely, objects with the same type of charge repel each other. Two positive charges will repel each other, and so will two negative charges. Static electricity is typically produced when certain materials are rubbed together, causing electrons to transfer from one material to another. This is best explained with an example. When you comb your hair with a plastic comb, static electricity is involved in making your hair stick up. Here's how it works. When the plastic comb rubs against your hair, electrons are transferred from your hair to the comb. This process leaves your hair with a positive charge because it has lost some of its electrons. The comb, on the other hand, now has a negative charge because it has gained electrons. Since like charges repel each other, the positively charged strands of your hair try to push away from each other. This repulsion causes the hair strands to stand up and move away from each other, making your hair stick up. This effect is a common example of static electricity, where the movement of electrons between objects causes a buildup of charge, leading to noticeable physical effects like your hair standing on end. Now that we've seen how static electricity can make your hair stand up, let's explore another fascinating effect: how a charged comb can attract small pieces of paper. We've seen how when you rub a comb through your hair, electrons are transferred from your hair to the comb, and consequently, how the comb acquires a negative charge. Now, if you bring this negatively charged comb near small pieces of paper, the electrons in the paper are repelled and move to the side of the paper farthest from the comb. This movement leaves a temporary positive charge on the side of the paper closest to the comb. The positive side of the paper is attracted to the negatively charged comb, causing the paper pieces to cling to the comb. This process is known as attraction by induction. In this scenario, a charged object, the comb, induces a temporary charge in another object, the paper, leading to attraction. The example we mentioned at the start of the lesson, a balloon sticking to a wall, is very similar to this. When you rub a balloon against your hair, static electricity is generated. This occurs because the friction between the balloon and your hair causes electrons to be transferred from your hair to the balloon. As a result, the balloon becomes negatively charged, since it gains extra electrons, and your hair becomes positively charged, since it loses electrons. Once the balloon is charged, if you bring it close to a wall, the negatively charged balloon repels the electrons on the surface of the wall. This causes that area of the wall to become slightly positively charged. This positive charge on the wall is attracted to the negative charge on the balloon, creating a force that allows the balloon to stick to the wall. The attraction between the opposite charges on the balloon and the wall is strong enough to hold the balloon in place. Understanding these foundations of static electricity helps explain many everyday phenomena, from the simple act of combing hair to more complex applications in physics and engineering. In today's lesson, we explored the phenomenon of static electricity. We discuss the basic principles of charge attraction and repulsion and how the transfer of electrons between materials can create static charges. By understanding these concepts, we've gained insight into how static electricity differs from current electricity and how it plays a role in various physical effects we observe in daily life. These foundational ideas of static electricity help us appreciate and explain many common experiences, demonstrating the fascinating ways in which electric charges interact in our world.